Hello everyone, and thanks for joining me for part 5 of the full stack Apollo GraphQL with React and Node tutorial. In this part we'll be adding pagination to our application. And the reason we would want to do that is that if we have a large response coming from our earthquake catalog, recall we're using the USGS earthquake catalog API to generate or to get a list of earthquakes in a certain time period. And if we get a lot of earthquake events in that JSON response, which looks like this, then it might take a long time for our page to load. And if that's the case, then the user really isn't going to be doing anything or able to do anything until the page loads completely, which could be frustrating for the user. So if you load the page in small chunks, which you can do with pagination, say 20 earthquake events at a time, then that makes it so that the user can quickly start examining the earthquake data, and then if they want to see more, they can click a button and load, say, 20 more earthquake events. And doing it's pretty straightforward. In fact, we're going to be given a bit of code as a freebie from the folks at Apollo Docs. So let's go ahead and get started. If you don't have your server running, go ahead and get it up and running now. And then once you do, open up your GraphQL playground. And let's take a look just at, say, an earthquakes query. Right, call it not quake, but quakes. Sorry, butterfingers today. All right, and then we'll enter in the subfields that we're interested in. For example, the magnitude, the location, when it happened, and the time that it happened. And recall, this time was a Unix timestamp that I told you we would use for our implementation of pagination, which we're going to do in this video. So we run that query, and we see our list of quakes. And if we scroll down and keep scrolling down and keep scrolling down, we see that it's a very long list, and if we try to return all this data at once when we load the page, it might cause the user to wait. So we're going to implement pagination now. One thing first though I'd like you to do, since we didn't do it earlier when we should have, is we don't want this to be time, right? We want to call this cursor, and I had originally called it cursor, and I think I ended up erasing that and putting in time. So if you recall in your Quake API, when we returned our custom data object here, we set the time as equal to quake.properties.time of that USGS response, or from that USGS response. All right, so let's not call that time, let's call it cursor, just so that we can follow as close as possible with the Apollo docs, as closely as possible with the Apollo docs. Go into your schema, of course, and change time to cursor. Right. Always check your schema and make sure that things are consistent. That's important. Go back to your query, and if you try to run it, you get an error because you can't query the field time anymore. All right, so if we get rid of that, and we call it cursor, and we run it again, things are okay. We've just replaced time, the time property, with cursor. Still get the same value associated with it. Okay, so now go to your Apollo docs and go to the part called paginated queries. All right, so first of all, they give you this launches method for your query type, and this is going to be a big update from the launches method that you currently have. So if you go into your schema, go to your query type, and then replace, sorry, theirs is launches, ours is quakes. I keep saying launches. But if you replace our quakes query with theirs, and you change these values appropriately, we should be good there. We'll also need to add this type quake connection as well. All right, so if you go back to the Apollo docs, you can see that they also give you the launch or quake connection type. And I encourage you to keep in the comments just so you can have them as a guide for what's going on. We'll go ahead and paste that in below the query type. And again, we need to change everything accordingly. Okay, so that looks all right. We should be good. Okay, back to the docs. Well, let's first look at the schema a little bit. Now, the page size is going to be how many earthquake events you want to load onto the page at a time, right? And it's going to take that in as an integer. And by default, we're going to set ours to 20. All right, and then if you go down, there's a value called after, and you'll pass that in as an argument. And this will basically be the cursor value associated with the last element that we see in the list. We're going to load 20 elements at a time, so if you load, say, the first 20 elements of the list, that 20th element, the cursor associated with that 20th element will be this cursor value, this after value that we pass in, so that it knows to start after that when you try to load the next 20 objects. And if that's not clear, don't worry, you'll see it soon enough. All right, and this quake connection is just a new type that we define that allows us to see what our cursor is, right, where we are. You know, if we're at the 19th index, or if we're at the 39th index, for example. This has more is a Boolean property, and it just lets you know if there's more data that can be loaded. And if there is, of course, you'll want to, or at least you want to have the option to load that. So, for example, if you have 300 items in your results array and you load the first 20, of course, you've got 280 left, and that has more will be true. When you reach the end of the list, then of course it will be false. And then, of course, as always, your list of quakes is just an array of quake objects. Okay, so now they tell you here to open up your utils.js file. And remember, we do have a utils.js file. It's just that in it, all we have is a store. But we'd like to add some more code. Right? We're going to add one more function to it, and it's going to be called paginate results. This right here. So let's go ahead and at least name the function. Good. Now let's get that data, or that code, excuse me. And we can do that just by going back to the introduction part of this tutorial. And if you go down far enough to the part where it says set up your development environment, you can see it says in your terminal clone this repository. Now you're not going to clone it because you're following along with my tutorial, but you can get the code from start, server, src, utils.js, and grab everything from the right side of the equal sign for the paginate results function all the way down to here. All right, copy that, bring it into your utils.js, paste that in, replace this with a comma because we're dealing with an object. All right, so now we have our pagination logic set up. We're not quite done yet, though. We also need to change our resolver. So if you go back to the Apollo docs to where we were at, they give us code for our updated resolver. Right, they have their updated launches resolver. Ours is going to be the updated Quakes resolver. But just grab that and copy and paste it into your resolvers file over your original Quakes resolver. Okay, you've got it there. And then you've got a lot of stuff to change, and I know this gets tedious. This will be Quakes. This will be all Quakes. And this will be Quake API. And this will be get all Quakes. Again, we get that from our Quake API here. All right, and then we want to display them in reverse chronological order. Almost there. And hopefully we haven't forgotten anything. I hope you're not sitting there on the other side of your computer screen yelling at me right now, calling me a dummy for missing something, but maybe I did. All right, so you can see now with this resolver, you're passing in as arguments a page size, as we already said when we looked at our query type for Quakes. It had an integer value for page size, and we're calling it 20 here. You have an argument called after, and we just talked about what that is. And if you're wondering how you pass that in, say on the front end, you can go to your playground. If you try to run this query now, right, it says you can't query field magnitude on type Quake connection. That's because we've changed the nature of our schema. Right, so now here these subfields are no longer valid where they're at. Right, if you hit Control Space, you can see that what you have available to you are your cursor. The Boolean value has more, which lets you know if there's more data that can be loaded or not. And then finally you do have your Quakes query. And then you can add in your subfields there. All right, so again, you have magnitude, for example, location, when it happened, and our cursor value. All right, so if we run it now, it says paginate result is not defined, and that's an oversight on my part. If we go back to the docs, all right, and you look here at the top of your resolvers, you're supposed to bring in your utils.js, the paginate results function from your utils.js file. So you can just copy that and directly paste it into your resolvers file. Okay, try this one more time. Okay, now we've got a list of Quakes, and there should be only 20 Quakes. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay, good. So our pagination is working. We're only loading 20. All right, so how do we know that we'll get the next 20 after these, right? Recall the cursor value, what it is it's the value that is associated with the last element in your in the elements that have been loaded onto the page. So for example, these constitute the first 20 earthquake events that are returned. So if we go down to the 20th element, which would be the 20th event, we can see the cursor value, and just try to remember 766,560 is the same as this cursor value, 766,560. So basically it's indexed in a way where we are at. It's telling you this is the last element of your first page, like the first set of results, and you want to return the results that come after this one. Okay, I hope that makes some sense. So if we go into Quakes here, we see that we have an after property that we can enter in a value, and what we'll do is we'll enter in this cursor value. All right. And if things are working correctly, then we should see a new cursor value pop up, which represents the earthquake event, the last element of the second group of 20 earthquake events that are loaded. So let's try that. Okay, so we don't get that. All right, we're getting the same exact cursor value. All right, so let's go back and look at our logic here. All right, so in our resolvers, you see that you pass in an after value, but the first time, recall that we didn't pass in a value for after. All right, we just ran the query as it was, and we got the first 20 elements. All right, and that passes in to your paginate results function along with the page size, and you also pass in the entire list of earthquakes, which was a few hundred, right? And it's going to break that up into small chunks, bits of 20 quakes at a time, right? So that gets passed into utils.js. And basically, since we're not passing in anything the first time, there is no cursor because after gets set to cursor here. Right? And if there is no cursor, it's going to return just the first 20 elements. You can see that because you start off at 0, the 0 index, and you go up to page size. In this case, page size is 20, so we're going to go up to index 19. All right, and then it's not going to continue on. Now in the case where you do return a cursor, then it's going to continue on and it's going to find the index of that cursor using this native function called findIndex. That's a JavaScript function. You can go to MDN Web Docs and see what it does. It says the findIndex method returns the index of the first element in the array that satisfies the provided testing function. Otherwise it returns -1, indicating that no element passed the test. So our testing function is in here. Basically what it does is it defines a value called item cursor, and it says if there's a cursor associated with that item, right, and we know that there is because it goes through each item in your results array, right, which is that list of 300 earthquakes. So we know that each item, and one earthquake event is an item, we know that each one has a cursor associated with it. So we know that that's what's going to get assigned to item cursor. In the case where you don't have something there, you can make up a function called getCursor that would just create an arbitrary cursor. Right? And it'll generate one for you, but we're not going to deal with that. And then our testing function says that if that value for your item cursor, which means when you get to that element that has a cursor value that's equal to the cursor value you passed in, which was your after value here, then it's going to return the index of that element. All right, that's what findIndex does here. And then once you have that index, it's going to look here and it's going to say, are we at the end of our list of results, which in this case is almost 300. And if it is, right, if your cursor index happens to be the last index in the list, then it's not going to return any more. But if it's not, then it will return a certain number of elements, right, where it'll start from the cursor index +1, as it should. It's the next one above where your last element in your last batch load was. And then it's going to go to either the end of the results array, or it's going to go to the cursor index +1 plus page size, whichever one is smaller, and that's what mathmin does here. Okay. And then in the case where your cursor index is negative, right? We said before it fails the test if it's -1. Then it's just going to return the first 20 results. And that's what it's doing for us right now. So somehow, even after we added that cursor value, we took this cursor value, right, and we put it in here for after. Right, we expected to see another 20 elements, or the next 20, but unfortunately we just got the same first 20 back again. Alright, and that may be because if you go to your schema, you see that I have the, for the quake type, our cursor should be a string, right? And our cursor is basically a timestamp, right? And if you look here, it's not a string. All right, so in this part of our testing function, we have a deep equals here, right? But we're saying that an integer is equal to a string, right? We're passing it in as a string, but this here is not going to be a string, right? So what we should probably do is go into our quake.js, our Quake API, and make it a string. So what if we do this, use a template literal. Let me go back to our playground. We run it again. And it did, it updated. So now we've got a new cursor value. So we are seeing the next 20 results. So again, the problem was this. We had a deep equals here, but we passed in a string and we were trying to see if it equaled an integer, right? Which our cursor for each item is an integer. You can see it here from the original JSON response. Okay, so how do you know that this is the next 20? I mean, the best thing I can say is to just go back, run your query one more time. So we're back to the first 20 results. Recall that this is the cursor value of the last element. It's this one right here. All right, so we're going to pass that cursor value in over here. But forget that. How about we pass in this cursor value? All right, so this is the very first element in the list. Now if we pass this in, according to our code, the first item in the next 20 results should be here, because we want to see everything, we want to see the next 20 after this one here. All right, so our first value in the list should be here. So remember that. Remember 8830. Okay, and let's pass this in as our cursor, or as our after value. So again, we want to see 8830 as our first value in the updated list. And there it is. It's the first value. So our pagination is working. We're basically seeing the next 20 results after the value where our cursor was marked. Okay, so that's it for pagination. It's not too difficult, given that we are given a fair amount of code for free from the, of course, for free from the folks at Apollo Docs. And when we hook this up to the front end, we'll see it a little bit more clearly how nicely this works for us. But for now, I hope that at least if you haven't dealt with pagination before, you can see now how it makes things go a little bit more smoothly. You don't have to worry about loading large data sets in one go and having to wait around for a page to load. So anyway, next time we will move on to the front end and we'll start dealing with React. But for now, thank you for